Morning, everybody. Morning, David. Glad to have you joining us. We're going to listen to a little music while we wait for some people to join us. All right. So hope you're doing all right, and hope you get out in the next couple of days and enjoy the sunshine that we're going to be having. We have an assignment that is in in your Google Classroom. A few people have finished this, and a lot of people haven't, which is why I'm going over it. And there's basically two concepts on this assignment. One is what an AU or astronomical unit is, and the other is what a light year is. Okay, and so a light year is actually a measurement of distance. A light year is a measurement of distance. I'm going to type that in here, okay? And it's a measurement of distance in basically an Earth year. You know, we think about everything from our own perspective, that we're here on Earth. So our year is 365, actually 365 and a quarter days to be exact. And so everything that we think about, we think from the perspective of ourselves and our Earth. And so a light year is a measurement of distance, basically how far light can travel in an Earth year. And so the answer to that is probably something that I've said most of us really can't understand or get our mind around. I know I can't. And here's the distance. I'm going to type that in there. And that is actually 10. And how many zeros are there? There's 9 sets of zeros there. That's 10 trillion kilometers. 1,000, million, billion, trillion. Every 3 zeros, the first 3 zeros are thousands, the second 3 is for millions, the third 3 is for billions, and the fourth set is for trillions. So 10 trillion kilometers. A lot of stuff in the scientific world is measured in kilometers. And so we have this thing where we have to kind of think about how far away the stars really are. Now, there's something called an AU, which is an abbreviation, and this is another unit of measurement, and it's called an astronomical unit. I spelled that right? Yep. Okay, and that is the distance from the sun to the Earth. Okay, again, we're thinking about things from our own perspective, and that it equals 93 million miles. Again, this time it's in miles. Most of the time we would use kilometers. So an astronomical unit is the distance between the Earth and the Sun, and so that equals 1. And so we can start measuring how far different planets are by using astronomical units in our own solar system. When we start talking about stars that are extremely far away, remember our sun is a star, and so the other stars are extremely far away. Now you're talking about things that are so far away that we need to measure them differently. We need to measure them in light years. And so our nearest star, and I know I've mentioned this, our nearest star is called Proxima Centauri, and it is 4.3 light years from us, okay? And so that's quite a distance, 4.3 light years. That is, how would we figure out how much that is? We would actually have to, and I'm going to do the math. We would have to take that 10 trillion and see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and multiply it times 4.3. Okay, and the answer that you actually get is 43, comma, 000, comma, 000, comma, 000. I'm going to put KM. Okay. All right. So if 1 light year is 10 trillion kilometers, our nearest star to us is 43 trillion kilometers away. What did I do? I actually just took 4.3 and I multiplied it times that 10 trillion kilometers. And so I showed you the math there. So I don't know if that totally loses you. But on this sheet that we have, this assignment that we have, basically what we do is instead of multiplying, we end up what we're doing is dividing. And so you can do this the long way or the short way. The short way, for example, and I'm going to show you my calculator. My calculator on my phone has 43 trillion in there. If I wanted to use a calculator to figure this out, I would just take that and divide it by 10 trillion. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you can see the math up there. And then the answer ends up being 4.3. Okay. And so when we have 43 trillion kilometers away, our nearest star, and we divide it by 10 trillion, which is 1 light year, it tells us that it's 4.3 trillion light years away. That's the way to do it with the calculator. There is another way to do it a long way, and I'm going to do a different star called Sirius, which is how Sirius satellite got their name. Okay, so if we had, and I'm sorry for using paper like this, But if we had Sirius, which is 90 trillion kilometers away, that's 90 with 9 zeros after it, and we know that a light year is 10 trillion. Okay, then we have something that looks like this. Okay, this becomes a division problem where you have 90 trillion kilometers away, that's how far Sirius is, divided by 10 trillion. Okay, there's a shortcut to doing this. If you're doing this without a calculator, you basically can go like this. You can cross all these off, and you end up having because you have to line them up when you do this. You end up having 90 divided by 10, and simply on the calculator, 90 divided by 10, which looks like that, gives you an answer of 9. And so in this case, 9 what? It's 9 light years. Okay. So I actually did the second problem on your assignment, and I tend to scribble when I'm writing fast. I apologize. That says 9 light years. And it's backwards when I look at it in the screen. And so any one of these, and I'll write that out. So Sirius is come on, computer. Garbage in, garbage out. Sirius is 90. 1, 2, 3, 1, 2, 3, 1, 2, 3 kilometers, and then we're going to actually divide it by 1 light year, which is 10 trillion kilometers. Here's how to do the math. And you end up with your answer, which I said was 9 light years. Okay, if you're lost, maybe you don't understand. So remember, in outer space with stars, we measure distance of stars in light years because of how far they are. If we have mathematical numbers, we can still figure out how far they are away in light years. If we just divide whatever number we have, it could be, 500 trillion, and we'd have to divide it by 10 trillion because 10 trillion is what you need to know. That's always going to be your divider. Everything to figure out a light year, you're always going to divide by 10 trillion. Your larger number would go on top like this, and you're going to divide by 10 trillion. Doesn't matter what star you look up, you have to find, or that's on our sheet, you have to divide it by 10 trillion. I hope you understand that. Now an AU is, and I have that written up here, it's 93 million miles. It's only 6 zeros. It's a lot easier number to look at. So I'm going to give you an example of, we're going to do one out on paper here. I got myself kind of a mess here. And I was actually been distracted today because I'm trying to teach myself how to do some digital downloading and adjusting PDFs and stuff so that I could. I've lived in a paper world most of my life, and trying to do things digitally is kind of tough for me. And so let's talk about Neptune. Neptune is distance from the sun, is 2.793 billion miles. Okay, so that is 2,793 million miles. And so I've actually written this out so you can see what it looks like. And I will write it, I'll type it in so you have it right there. Hey, Trevor, good seeing you, buddy. Thank you for joining us. And so when we're talking about, now we're talking about astronomical units or an AU, okay? Remember the AU is the distance between the sun and the Earth, okay? And so it's 93 million miles, okay? And so Neptune is 2,793 million miles from the sun, okay? And so how do we figure out, instead of using these huge numbers like 2,793 million miles from the sun, we can actually use astronomical units, because we know an astronomical unit is 93 million miles. That's the distance from the sun to us, okay? So we can take the larger number, which is 2,793 million, and we're going to divide it by 93, 1, 2, 3, 4, 5, 6 million, okay? And we'll get an answer for that. And again, I'm going to use my calculator on my phone, and we're going to divide it by 93 million, okay? And the answer we're going to get, in this case, if I can get my, it's funny to try to be using your phone when everybody's sending out text and stuff. 30.03, and we'll leave it at that. So 30.03, we'll round it off, AUs, okay? And so the distance of Neptune to the sun is 30 AUs, okay? So then we have to ask, okay, then how far might it be from us? Part of that depends on where we are in the solar system. What do I mean by that? Remember, sun's in the middle. We're going around the sun every 365 and a quarter days. If you don't remember or not, this was a leap year. And so that's the makeup for those quarter days. Every 4 years we have a leap year. All right, so the problem is we may be over here and Neptune may be way out here. So let's assume that we are lined up, then we could actually say how far are we on Earth away from Neptune. Kind of really simple what you have to do. You have to subtract 1 AU from whatever you're measuring if we were lined up to get our distance from that planet. Now you understand that changes all the time. In this case, you have Neptune, which is 30.03. I'm not typing. Thought I was typing. Neptune, which is 30.03. And this is subtraction. Minus 1 equals 29.03. That's really simple. We're just going to subtract R1 AU from the distance from Neptune to the sun. So assuming that our planets were lined up at a certain time in a cycle, then we are actually at that point 29 AUs away from Neptune. The other time of year, you might have to add one because we'd be on the other side of the planet, of the sun, and we'd be 31. All right, so this basically explains how to do, where is it? Somewhere over here. The assignment that we have on there, and it's mostly about light years, but there's a few examples of an AU. And so here's what I want you to do in addition to what's on the assignment. I want you to choose any planet that is in our solar system besides Earth and figure out how many AUs it actually is. So choose any planet and figure out how many AUs it actually is, and you're going to add. I will post that assignment, and maybe I'll have you do two. And so you just have to remember the numbers based off of this sheet. So, and these are short sessions, and I appreciate you guys joining. Is anybody, if you feel lost, that's okay. I understand it. If you have questions, please ask. If you're not sure what question to ask and you're not going to know it until you start working on the assignment, that's okay too. You can message me in the Google Docs or email me. Apparently we're having some trouble with our email system right now. But as soon as I am able, I will get a hold of you guys or get back with you guys if you have any question. I appreciate you being on, guys. I appreciate seeing you, Trevor and David. I'm glad you guys were able to join us. Some other people joined us on Tuesday, and we're able to get all this done. And this is kind of a repeat for the most part of what we did on the other day. And so thank you for joining us. If you doesn't look like anybody has any questions or maybe not know exactly what they even need to ask, get on your Google Docs somehow. You can look at it. If you should be able to get on it even on your phone if you can access it. You can even write the answers out on a piece of paper. You're welcome to use a calculator, and you can take a picture of your answers on a piece of paper and email it to me. Again, I always leave my email at the end. And I am about done. Okay. Time for some bumper music. Hope you guys are having a good day. Get out there next couple of days. It's supposed to warm up. I think Saturday it's supposed to be in the 60s. By the way, next week is spring break. But for the rest of the month, so there won't be any live streams next week. The rest of the month we will be on. So please join and please watch because you have assignments that are part of your grade that will be due. Take care, guys.